In this video, we're going to take a look at writing piecewise functions. So we're going to write an equation to represent each graph below, and then we're going to identify the domain and the range of the graph. So for example 1, the equations of each piece of the function are already pictured here. So we just need to transfer those over to the piecewise function on the right. So for this first piece, I can see y equals x squared. So f of x is like y equals, so you don't have to write it twice. You've already got it out front. So just put x squared inside the curly brace. You can tell that the x values are going from negative infinity up to where x is equal to 2, but then it's an open circle. So we would say x is less than 2 because those are the values of x represented by that piece of the function. For the next piece, we see a little dot right there at y equals 6. So we just need to bring over the 6 and write it down because we've already got the y equals out front. So just put 6. And then we can see that y equals 6 is just a dot, and it's located at the point where x equals 2. So that's what we write for the domain. And then the last piece of the function is this little piece of a line over here. And it says y equals 10 minus x. So you just write 10 minus x. You've already got y equals out front. And then you can tell that the values for x, the domain for this piece of the function, goes from x equals 2 over to where x equals 6. So from 2 to 6. And then the first circle is open. So it would be where x is greater than but not equal to 2. And then this circle is closed at the 6. So it would be less than or equal to 6. And then that is what we write for the domain. Now, for the overall domain, you look at the whole picture and see what's going on. So you check and see, is this graph going left to right forever? Is anything missing in between? So it's going over here to the left forever, and then it continues on, and you can tell that the value for 2 is included where y is equal to 6. And then you can continue on over here to where x is equal to 6. So it does not go forever to the right. So we need to write the domain goes from negative infinity over to where x was equal to 6. And it's equal to that point, so we put a bracket. For the range, you look at how low the graph is going. Like for your y values, what's the lowest possible y value? Which looks like that would be where y equals 0 for this graph. And then we can tell that this first piece of the function is going to go up forever. So as long as one piece of the graph does that, then it's considered that the whole graph is doing the same thing that each piece is doing. So we would say that it's equal to 0, so put a bracket, and then it's going to go up forever, so put infinity. So from 0 to infinity would be the range. All right, let's look at number 2. So number 2, you have to pick out the equation of each piece of this function, which you have all of your math skills to help you with this part. So for this horizontal line, that is just the line y is equal to 2, because it's a horizontal line. That's a good way to remember horizontal lines are always y equals. So let's write that y, remember that's like our f of x, so y equals 2. And then it's for the values where x is, looks like it's equal to this number, and then it's less than. So that looks like negative 1. So it's for values where x is less than or equal to negative 1. Then you move to the next piece, and you see what is the equation of that piece. Let's zoom in a little. So we see we have a y-intercept at 2. So think about y equals mx plus b. So a y-intercept is your b. It's at positive 2. And then we can tell this has a slope of negative 1 because it's going down 1 box and over 1 box each time you go from point to point. So negative x plus 2 would be our second piece of our function. So negative x plus 2. Then check out the domain of just that piece of the function. It's going from where x is not equal, it's open. X would be located at negative 1. And then it goes over to 2 where it is equal because that's a solid dot. So we need to write x is greater than negative 1 less than or equal to 2, because that is what part of the domain this takes up. All right, let me scoot over there and move that into place. Okay, now the last piece of the function, I'm gonna highlight it with another color, is just another horizontal line. So horizontal lines are always y equals, and this one is located at y equals -1. And so let's just write that over here, y equals -1. And it's going from where x is located at 2, but it's not equal to 2. And it goes over to the right forever. So that would represent that x is greater than 2, but just not equal to 2. All right, now we look at the domain and range for the entire graph. So you stop focusing on each piece and you look at the entire graph to see what is happening left to right and what is happening from the bottom to the top. So for domain, we go left to right. So are all of our x values represented? Let's see, we got -1 is represented. Then we can continue on. 2 is taken care of, and we can continue on. So all of our x values from left to right are taken care of. They are included. So put -infinity to infinity for that one. Then the range are the y values. So in this case, we can't go up like from this point where y is equal to -1 to where y is equal to 0. There's a little gap right there. So we got to write that according to what we see. So we see that y would go from -1 to 0. It's equal to -1 because there are points that are equal to that number that would be solid. So you put a bracket, and then at 0, there's a bracket because that's a solid dot. So that's the first part of our range. It goes from -1. Whoop, I'll take that back. That's actually the gap. So let's back up. Back. That is what's not included. So what we need to say is y is just equal to -1 all by itself. And then we have to skip that gap. I was focusing on it. I'm sorry. Let's back up. So just -1 is the first part of the range. Then there's a gap. And then the next part of our range goes from where y is equal to 0 up to where y would equal 3. But then it's not equal to 3. So we'll put a parentheses there. So it's from 0, but it's equal to 0. So we need to put a bracket. Then it goes up to 3 and put a parentheses. So in math, we write a U, that means and. So it's from -1 is one of our parts of our range, and we put the little U symbol. It goes from 0 and it's equal to 0, so we put a bracket, and then it went up to 3, but it was not equal to 3. Now let's see if we took care of everything. We've got, let me grab a purple highlighter. We have this piece included, and we have this piece included, and what's already been included is the value of y equals 2, because that's between the 0 and the 3. So we've taken care of everything. All right, let's look at another graph, and then we'll just check out 2 quick word problems. So for this graph, for number 3, you want to first write the equation of a piece of the graph. It doesn't matter which one you start with. I just usually try to go left to right. So I see that this horizontal line is located at y is equal to 1. So remember, f of x is like y equals, so you don't need to write it again. It's usually already there, or you just write it out front. Then put the 1 inside the curly brace. Then you see what values of x is this part of my graph located in. So I see -1, but it's not equal to -1. And then it's going off to the left forever. So we would say that it goes from where x is less than -1, but not equal to. That's all the values that are headed over there to the left. Then the quadratic function, usually they won't give you anything too terrible. So this is just x squared, and we can tell that it shifted down a bit. So it's normally located at the origin, but it shifted down 3 units. So this equation should be x squared minus 3 And you could type that in Desmos to verify, but I'm going to go ahead and tell you that's what it is for this one. And that's how I can tell. And for the x values, it's going from where x is -1 and it's equal to -1. And then it's going forever to the right. So we would just write that out as x is greater than or equal to -1. Since there's only those two pieces, that's all you have to do to set that up. But now let's look at the overall domain and range for the whole graph. So you stop thinking of them as pieces at that point, and you think of what is happening from left to right overall. So I've got all the values of x from the left up to -1. Then -1 is included on the second piece of the function. And then it's going to the right forever. So it is, once again, all real numbers. They're not always all real numbers, but they do have a lot of examples that turn out that way. So don't think always, but often. That is the case. So then let's look at the range. The range is the lowest y value, which looks like it's right there at -3. And it's equal to -3, so let's put a bracket at -3. And then this quadratic function is going to continue to go up forever. So we could just put -3 to infinity. Okay, so that's it for page 12. Let's look over here at page 14 and just write out 2 word problems. All these words look like more than they are, but they're really pretty straightforward. It says a t-shirt company sells t-shirts for $12 a piece if you buy 10 or less. All right, so let's just first stop there. If they sell t-shirts for $12 a piece. All right, that's the first scenario, $12 a piece. If you buy 10 or less, so that's where x is less than or equal to 10, because 10 or less would need to include the 10. For the second part of the function, it keeps giving me a small pen, so I'm going to try to make that bigger. Okay. It says if you're willing to buy between 11 and 50, they will cut you a deal and sell them to you for $10 a piece. All right, so cost is over here on this side, $10 a piece. And that's if we get between 11. So between 11 and 50. And let's say it's equal to, because it could be you buy 11 and up to 50 is what it sounds like. And then it says if you are willing to buy more than 50, all right, so x is greater than 50, then you would only have to pay $8 a piece. So there are 3 scenarios, and you just have to write them according to how they state them and then think about the symbol you would need, and that's it. All right, so let's try one more of those. Number 2 says a teacher wants to take her students on a field trip to the local zoo. The zoo charges admission to groups according to the following policy. Groups of fewer than 50 people are charged a rate of $35 a person. So typically we have cost and then like amount of the item is over there on the other side. So notice this one is similar. We're going to have cost and we're going to have amount of like people over there. So the zoo charges admission groups of fewer than 50 people. So X is less than 50. They're charged $35 per person. So we could just put that there. And we could put 35X because X would be how many tickets we buy. So let's see. While groups of 50 people or more are charged a reduced rate of $30 per person. So that would be our next function. $30 per person. So put 30X. And that's for 50 or more. So greater than or equal to 50 would make sense with that statement. All right, so we are just practicing writing these functions, and that is all you would need to do to write them out. So that's it.